Hey, Brady, and are we missing somebody else? Megan. Brady and Megan. Related rates, we've done like the first, I don't know, handful of examples, but we're going to do example 4 and example 5, and hopefully that will help to refresh some things. Okay, so give me your full and undivided attention. I would if I were you on every single one of these homework problems. Shh. Write out the equation that you're going to use, what you're given, and what you're trying to find. Shh. Okay, listen. Shush. Shush.
This is not my pencil.
Okay, whatever.
You guys are.
Equation given, find. All right, listen. Here we go. We have a diagram. Shows a camera mounted at a 300 foot from the base of a rocket launching pad. So we know that the distance from here to here is 300 feet, or 3,000 feet, excuse me. Now, is that going to change?
Probably not.
No, so like let's say we call this side A, this side B, this side C, because we have a right triangle, right? Okay. A is going to be equal to 3,000, yeah?
Yeah.
dA dt is the rate at which A changes with respect to time. What's dA dt?
0.
I wouldn't put 0 in there. I just put like 1. Like it's not doing anything. It's changing the same amount per the same units of time. It's like not changing at all, right? So dA dt is constant. It is not changing, right? So there's that. Okay.
1 means that it like increases 1. Like if you because the derivative of a horizontal line is 0. That
He's got a point.
that is true. It's just like a horizontal line.
You might be right.
No matter
So
what the time
so
is,
should we put 0 in there?
it's
I don't know. I'm gonna have to think about that. Yeah, let's go ahead and put 0 in. dA dt is the rate at which A changes with respect to time. Let's put 0 in. Okay, we'll see. Then we need to know what B is. We need to know dB dt. Is B going to change as the rocket launches? Yes, yes, yes. And it's going to get faster the further it goes up in the air, true? Okay, because initially it's going to be going slower, then it's going slower when it's like up in the air, right? Okay, that makes sense? Because like the rocket doesn't automatically start going 1,000 miles an hour or whatever it goes. C is this guy, and dC dt, is that going to change? Is that length right there going to change? Yes, right? Like that distance will change. Okay, so it shows the camera. It's 3,000 feet from the base of the rocket. If the rocket is rising vertically at 880 feet per second, it is rising vertically at 880 feet per second. Which variable is that? That is dB dt. That is the rate at which the vertical distance is changing. It is at 880 feet per second. Okay? Now it's going to gradually get larger than 880 feet per second, right? Because it's going to start going faster. But at this certain instant, it's going 880 feet per second, like speed, right? Okay? When it is 4,000 feet above the launching pad. So what is 4,000? B. That's just B, right? Okay? So it's changing at 880, but it's exactly at 4,000 feet above, right? Okay? How fast must the camera elevation change?
So they want dC dt.
They want dC dt. How fast is the camera angle changing? Yeah?
So C doesn't technically matter. That's right.
But we will need it. We will need it when we do the equation. So I'll show you that here in just a second. Okay? So our equation is going to be what? We don't have an equation. But what do we have going on here?
A squared.
Yep. That's the equation that we're going to use. A squared plus B squared equals C squared. Given. I don't know, all the things that we have over there. We know that B equals 4,000. We know that dB dt is 880. We know that A equals 3,000. I guess we know dA dt, kind of, yeah.
We know C.
We do know C. We don't know C, but we do know C,
But-
right?
Yeah. 3, 4, 5.
Yeah.
5,000. Yeah.
Okay.
Yeah.
It's 5,000, right? 3, 4, 5. Okay. All right.
We're finding dC.
Okay. All right. Okay. Now, here's the deal.
No D.
I think Jacob's right with the fact that this is 0, but I'm gonna show you. I'm gonna show
launching
you
pad
why.
But
I'm gonna show you why.
Yeah.
Right? So C is or A is not changing, right? So we can either plug 0 in for dA dt, or so let me show you options, right? The next thing we're trying to find dC dt. dC dt. Okay, that's what we're trying to find. Question mark. Boop. Okay. Now here are your two options. Ready? We find the derivative of him, right? And that is 2a dA dt, right? Plus 2b dB dt equals 2c dC dt. Yeah? Okay? And we start plugging things in. Yeah? And we start plugging in, like A is 3,000. Yeah? dA dt is 0 because it's not changing. 2b is 4,000. dB dt is 880. Oh, by the way,
There's so much writing I can't see.
also, be careful of the fact whether it is changing in length in the positive direction or changing in length in the negative direction. For example, if this rocket was falling toward the Earth, this would be a negative 880.
So you need to put 880 in it.
Yeah, I know. 880.
Can you
Okay?
zoom out?
Equals 2
Can you zoom out?
C.
Times 5.
We know C is 5,000, right? And dC dt is what we're trying to find.
Stop, Travis.
Okay.
Divide the whole
All right.
thing by 10,000.
Now here's the deal. This goes away because we're taking it times 0. Yeah? Okay? This guy right here is, I don't know, 8,000 times 880. I don't know. That's a big number. This is 10,000. Right? dC dt.
7,040,000.
7040.
Yeah. And that's
000. I'm going to divide that by that number. So I'm going to knock off 4 zeros, I think. 704 dC dt is 704. Yeah?
Why'd you say?
And that is the rate at which the camera angle is changing with respect to time. So that is 704 what?
Feet per second.
Feet per second. Okay. Now, that is doing the derivative, all like we care, whatever. Or you could do this, right? Because A is not changing, right? A is constantly going to stay 3,000, right? What I can do is I can plug in 3,000 in for A. Okay, here's what I can do. I can plug 3,000 in for A to begin with because it's not going to change, right? A is not going to change. I can plug that in before I take the derivative, right? But this is going to end up being like 9 million, right? Okay? Plus B squared plus C squared. What's the derivative of 9 million? 0. Okay? And I could do it that way. Does that make sense?
Oh, true.
Yeah?
I didn't even-
So regardless of whether I look at it this way and plug the 3,000 in first because it's not changing, or I take the derivative and plug in 0 for the change, either way I'm going to get the same answer. Got it? So you can look at it either way. What?
What if you would have left 1 in?
Number 1 rookie, by the way.
Then it would have been wrong.
That would have been a number.
It should be 0 because it's not changing. Yeah. I was wrong when I said 1. Okay. All right. Moving on. Example 5. Okay. Suppose that we've got liquid in this container. Liquid is to be cleared of sediment by allowing it to drain through a conical filter that is 6 centimeters high. Okay. It's not 16. 16 centimeters high and has a radius of 4 centimeters at the top. Okay. So the height is 6. The radius is 4. Those are the things that we've got going on there. Right? Okay. Now, as it goes down, the radius is going to change. True? So the radius will get smaller. The height will get smaller. Yeah? Okay? All right. Now, is the rate that the water is dripping out of here going to be the same?
Yes.
Yes. Is the rate at which this height is changing going to be the same?
No.
It's going to feel like it's going really slow, and then all of a sudden it's going to go whoop, right? You know, like a
Yes.
what is the sand dot? What is the
Hourglass.
hourglass? I don't know why I can't think of that word. Okay, it starts and it goes and it goes and it goes and it goes and then it goes really fast, right? Okay, so that is going to not stay the same, but the volume at which it drips out is going to be the same. Yeah.
Yeah.
Like it's going to drip at a constant rate. Okay,
Indubitably.
So will that be a 1 gallons per minute?
no.
GPM? 0.
Centimeters.
Okay, it's this, hold on, we'll get to that. Okay, do you think that the depth of the liquid will decrease at a constant rate?
Get people
No.
per minute.
No, the depth of the liquid is like the height. No, it's going to speed up. The depth of the liquid, like as it goes down and down and down, it's going to get faster, right? The depth of the liquid is going to speed up. Yeah, how tall?
Yeah.
Like, that's what they mean by the depth. Find a formula that expresses the rate at which the depth of the liquid is changing in terms of the depth, and use that formula to determine whether your conclusion in part A is correct. All right, here we go. So, we need the volume of a cone. Do you know what the volume of a cone is?
1/3.
1/3 the volume of a cylinder, right? Okay. Volume of a cylinder is the area of the base times the height, right? How do you find the area of the base of a cylinder? Pi r squared times this is the area of the base times the height.
Oh, yeah.
Okay, that's volume of a cone. It's 1/3 the volume of a cylinder. Cylinder is area of the circle times the height, right? Okay, so I've got that going on. Yeah, yeah?
I didn't.
Okay, that's going to be my equation.
I just said it.
I paid attention to my sheet.
So I was right.
Let's do part C.
Everybody.
At what rate,
Every math, the whole class.
hold on, at what rate is the depth of the liquid changing when the cone is 8 centimeters deep?
Is this a
Okay.
product rule because the
Yeah, that's going to be a product rule.
ew.
Okay? All right, so the only thing they give me to plug in is that this is 8. At what rate is the depth of the liquid changing? Okay, so what are they using to refer to as depth?
The height.
The height, right? Okay, so at what rate is the depth of the liquid changing? What are we trying to find?
You need to find the height.
Nope, you're close.
You need to find the rate, the R.
Nope. At what rate is the depth changing?
The
volume.
Oh, you need to find the
Rate.
DH.
dH dt is what we're trying to find, right? The rate at which the height, which they call depth, at what rate is the height changing with respect to time, okay? When the liquid in the cone is 8 centimeters deep. So what are we given? What is 8? The height itself is 8. Not the change in height, not the rate at which the height is changing, just the height itself. Yeah, yeah? Okay.
DHDT is negative, right?
Yeah.
Yes, dHdt should be a negative number. Yeah.
No.
Yeah, correct, because it's going down, right? It's getting closer. Okay. All right, so what should we do now?
Product rule.
I'm going to do the product rule. Let's find what this is and figure out what all we're missing, right? Okay. So starting from left to right, what's the derivative of V? dV dt equals, this is going to be a product rule. So this guy times this guy plus this guy times this guy. What is your F part going to be?
1/3 pi R.
1/3 pi r squared. This is your G. So that whole thing is F, that whole thing is G, right? Okay. So F prime, yeah, I like that. 2/3 pi r dr dt. Don't forget it. Yeah, that's the derivative of your F, right? G is just going to stay H. Yeah. Okay. The derivative of G, or the derivative of H, is dH dt. And then we've got just the F, 1/3 pi r squared. Perfect. Okay. Oh. Wait a second. Suppose also that the liquid is forced out of the cone at a constant rate of 2 cubic centimeters per minute. What is that?
The rate.
The rate of what?
The DR.
Yep, is forced out of the cone at 2 centimeters per minute. Okay, so dV dt is what? -2, right? It's going down at 2 cubic centimeters per minute. That should tip you off. Cubic centimeters is going to be volume, right? Okay, the rate of the volume changing is -2. Okay, so we've got that. All right, so let's figure out what we need. Yeah, we're trying to find dH dt. I'm gonna get rid of some of this stuff. This is what we're trying to find, right? We know dV dt is -2. Okay, so we've got 2/3 pi. We need something to put in for R. We need something to put in for H.
H is
And we need something to put in for dr dt.
H is 8.
Oh,
Because
we
the
do know
radius-
8. We do know H is
We
8.
took the 2
And
down in
isn't
it.
the radius
Yeah.
4?
Is the radius 4?
From
No,
like,
that's at the top.
That's at the top. We don't know what the radius is. So okay, but hold on. We can find what the radius is. So here's the deal. If at the very top, this is 16 and this is 4, that's a proportion, right?
1/4.
The radius is 1/4 of what the height is. So if they're saying that my height right now is 8, what's the radius?
2.
So I can plug that in there, right? Do you see how we arrived at that conclusion? Right? Okay. I know the radius is 2. Okay. All right. We need to figure out what dr dt is, but we'll get to that. Okay. We have to have something to plug in. I don't know why I have an equal sign here. Okay. Plus 1/3 pi r squared, and then dH dt. dH dt, right? I'm kind of mixing stuff around. Okay. R we said was 2. All right. So we need to find dH dt is what I'm looking for, right? This is what I'm trying to solve right here. Okay. So I need one more thing.
You need dr.
I need dr dt.
How much? The rate. How much the radius changes?
How much the radius changes with respect to time.
dH over dt.
It doesn't say what the change in radius it is.
So we can't do it.
No,
Well,
no. We just gotta think a little bit.
that's a mystic, bro.
Thinking.
Then don't think and just freeload off of other people. Trust.
Agreed.
Okay, okay. Let's do this. Ready? Okay, hold on. We drew some conclusions over here, like how we solved for R, right? This is like the hard part. This is like the part that like you have to fill in and use your brain actually. The rest of it's just plug and play, right? Okay?
Oh, no,
So the deal here is that we know that the radius and the height are in what relationship to each other?
Directly related.
They're directly related. It's a direct relationship. What? Where do you want to put? You want to put 4 or 1/4?
4.
4. So 4R equals H, right?
Oh,
Okay.
yeah.
Yeah. So we know that that's going on. All right. Now here's the little tidbit.
Radius is 4, the height is 16. So it like changes.
Yeah.
So like when it's 8.
Yeah. The height is always 4 times what the radius is. Yeah.
To 1/4.
Should we switch it to 1/4?
Yeah, so we can.
Yeah, that might be easier. Yeah, that might be easier. Let's go 1/4. That's fine. Okay. Now, we know that this is an equation that we can use, right? We know that this is a thing. Let's take the derivative of this guy. Okay? So if I take the derivative of R, that's dr dt, right?
Oh,
Which is what we need to be able to plug into here, right? Okay?
Yeah.
But if I take the derivative of 1/4 H, that's 1/4 dH dt, right? Okay? But we know that dH dt is what we're trying to find, right? Okay?
You just plug in 1/4 of DHD.
But I'm going to plug in 1/4 dH dt right here, right?
Because it equals DRDT.
Zach, stop thinking.
Okay?
Zach, let's keep.
All right.
Let's keep
You see what we just did? We just switched all our variables so that we have just like the same thing that we're solving for. Now we got it kind of a mess, but let's clean it up, okay? Do you see what we did?
Yeah.
Find the derivative, start plugging stuff in, right? This one is one of the harder ones.
Are we gonna have
You might have like one like this that you have to like think this hard,
love
okay?
thinking.
All right, here we go.
Wait,
So
is that-
let's
hold on,
simplify.
I have a question. Is that a -2? Is that what that?
No,
little
that's
line
not
above
supposed to
it
be a
is?
dot. That's not anything.
Oh,
No. Okay. All right, so let's put stuff together. We've got 2/3 times 2 times 8 times 1/4. 8 and 1/4 makes 2, right? So that is 4, right?
Yeah.
And that's 8/3 pi. 8/3 pi dH dt. Got it. Plus, what will that be?
Wait.
4/3
4/3 pi dH dt. Okay, we're so close. Now what would you? Can you add these? Those are like terms, right? What's 8/3 plus 4/3? Which is? So -2 equals 4 pi dH dt. Okay, how do I solve dH dt? Divide by 4 pi,
Oh yeah, that also works.
right? Okay, so dH dt is changing at a rate of what? Negative pi over 2. What for what? Centimeters per. Is it minute? Oh, wait. You're right. Pi is on the top. That's not right. 1 over 2 pi. You're right. -1 over 2 pi. Thank you for that. What is it? Feet per? No. Centimeters per? Is it minute? Sure. Is changing. Now, the height is going to get more than that, right? Like the further it goes, it might get up to like -2 centimeters per minute or -3 centimeters per minute because
But
it's
this is
going to
what
start
it's
going
at
faster.
2
But this is
centimeters.
when it's exactly at that height, at 8 units or 8 centimeters high, it is going that fast, decreasing. Yeah? The height is decreasing that fast.
It's starting to click.
Yeah.
So like,
Mhm.
if it was lower by like a millimeter.
Yeah, it would be higher than -1.57. It would be like 1.8 or something. Yeah.
Maybe it made sense last week. I'm just.
Okay, good. So I encourage you on these problems to like separate your stuff. Equation, given, find. If you don't know, if you've written all the given down, start to take the derivative and fill in the pieces, right? That's a lot. That's a lot of stuff. Okay, all right.
That's French. La hospital.
There's no S in there. It's called l'hôpital.
L'hôpital.
L'hôpital's rule. Yep. It's French. Is that French? It sounds French.
So is
L'hôpital.
Poisson.
Oh.
What?
In statistics. In statistics.
What?
In statistics.
It is?
Poisson. Yeah, it's fish.
It's called poisson.
Okay,
Poisson.
literally, I look at it and I think
Poisson.
Mark.
Poisson.
Stop, you're gonna make me
Steve
drop my
Le-
croissant.
Okay, all right, goodbye.
Hey, Kelly.